Today I'm going to explain example 4, chapter 5.4. So it said find the relative extrema for f function of x equal to minus 3x to the power of 5 plus 5x to the cube. Step 1 is to find the critical number of function. So function x is equal to minus 15x4 plus 15x squared. And then we just put this one as 0, and then and this one come from this one differentiate of this one. And then we put this, I put this on as zeros because as we know that critical number is the equation equal to 0, so that we could find what value of x is 0, which is critical number. So then we separate it into two parts. So 15x squared equal to 0, so 0 equal to x, and then 1 minus x squared equal to 0, so we get plus and minus 1 equal to x. And then we use the second derivative test. So this one, and then we differentiate it again, so it will become minus 60x cubed plus 30x, which can be separated into 30 minus 2x cubed plus x. And then we make a graph composing of point, sine of x, second derivative, and conclusion. Actually the one that I say differentiative is like derivative. I just said it wrong. And we put the point in, so the point is minus 1 and minus 2. F derivative is more than 0, and so we can conclude that it is relative minimum. And then 1 and 2, F1 will be lesser than 0, so this will be relative minimum, so it will be negative. And then 0 and 0, which is F, when we put it in derivative, second derivative equal to 0, so test fails. And if you question where I find this number, so it is here. Everything is all here in critical number, so I put it here. And then let's look at the graph. So because the second derivative test failed at 0 and 0, we can use the first derivative test and observe that f increased to the left and right of x equal to 0. So 0 and 0 is neither a relative minimum nor relative maximum, since it's constant here. That's all for example 4. Thank you.